Hey guys, this is Kerry, and in this video we're going to be solving systems of equations graphically. So we saw that we can solve systems of equations graphically by hand when the equations are easy to graph, like lines. We can use the same technique to solve systems of equations that are harder to graph by graphing these equations on our calculator. So let's take a look at problem number 1. So which of the following is the solution to the system of equations shown below? Alright, so we press y equals. Oh, and I've already got this stuff in, but you might have other stuff in your calculator. So if you want to do a complete reset, let's start off like that. Second, memory, 7, 1, 2. All right, so now I've reset my calculator, and I'm ready to do a brand new problem. So I press y equals, and I'm going to put these two equations in the calculator. So 1 divided by 2 times. Now, we haven't talked about this operation with the bars here this year, but you've probably seen it from Algebra 1. It means absolute value. So to graph an absolute value equation, we need to put the absolute value function on our calculator. So to get this function, you press second catalog, and the very first function that comes up is called abs, and that stands for absolute value. So if you press enter on absolute value, it's going to look a little different on my computer than on yours, but it gives me the two bars just like it looks like here. For you, it likely says abs followed by a parenthesis. It's the same thing. So I'll do the absolute value of x, and then you're going to have to close your parentheses. For me, it automatically closes my line like this. Next up, the second equation is 3x minus 9. So we graph that just by typing it in. To solve the system, we need to know where they intersect. So we press graph, and let's see how it looks. All right, so I've got the absolute value, and now we've got the linear function. So to find out where they intersect, well, one way to do it is to just press trace on your calculator. And what trace will do is it will allow you to trace the blue curve here. So I'm going to trace along the blue curve until I hit the point of intersection. And it looks like the point of intersection is like, showing up as like close to, it's not exact, right, because I'm just tracing along it, close to like 3.6 and 1.8 for y. I'm getting those values from down here. And because the answer choices are so far apart this time, it's pretty clear that the answer choice must be the one that's closest. It's probably 3.6, 1.8. Awesome. So we're done with problem number 1. This is the solution to the system of equations because it's the point of intersection. Problem number 2 is going to force us to be a little bit more careful. Let's see why. So which of the following is the solution to the equation 2 to the x power equals negative 1 over 3x plus 5? So we talked about this last class. Equations of this type are impossible to solve in a closed form algebraic way. They're called transcendental equations. I didn't say that last class, but I think the vocabulary might help you. So transcendental. And to solve transcendental equations, because algebraic solutions don't work, we often solve them graphically. But this problem looks a little strange. How are we supposed to solve this graphically? It's just one equation instead of two equations like we had above. So the way you can solve this graphically is, let's go to y equals. I'm going to clear out the two old equations. To solve this one graphically, what you're going to do is you're going to enter this one as your first equation. And you're going to enter the other side of the equation as your second equation. And to find out when the left side, 2 to the x, and the right side are equal, what we're going to do is we're going to find out where the two sides of the equation intersect graphically, and that will tell us the x value that makes these two equations, or these two expressions, equal to each other. So you get negative 1 over 3x plus 5. Great. All right, so we graph it. And so we've got 2 to the x coming out first. It's an exponential. Looks good. Now our second equation should be linear with a decreasing slope. Let's see. Yep, excellent. And so the value of x that will make the two expressions equal to each other will be the point of intersection. So if we try what we did last time and press trace, let's see what happens. So we trace along the first curve until we hit the point of intersection. All right, so it looks like my point of intersection is like 2.1-ish. Crap. If we look at our answer choices, all of our answer choices are 2.1-ish. And there's no way for me to get more exact than get the right level of precision by just using trace. So luckily, if trace fails because the answer choices are so close to each other, or because you need a more exact point of intersection, we have a function on our calculator that will let us determine the point of intersection. So to do that, instead of doing trace, we do second calc. Now the thing we want to calculate is the point of intersection. So we choose option 5. To choose a point of intersection, you can choose any point on the first curve. So see how it asks that question at the bottom, first curve? Your cursor will likely appear on your exponential. Anywhere you press enter is okay. It marks that that was our first curve choice. The next question is, what's the second curve that we're trying to find the intersection point for? Well, that's going to be the linear curve. So we press X on the linear curve anywhere again. Now the final step is, it needs us to take a guess for where the point of intersection is. So now tracing along the second curve, using the right and left arrow keys, try to click enter as close as you can to the point of intersection that you're trying to find. So you press enter. Now it does some crazy calculations, and let's see. It says intersection, and it gives you the point of intersection. So the point of intersection for our two curves is 2.1039004 with super precise precision. Y equals 4.2986999. And let's see, which answer choice is this? Okay, well, it looks like it's 2.10, and then to the nearest thousandths, we've got to round up because of the 9 to 2.104, answer choice 2. So a couple of things. You might be wondering, why isn't there a y-coordinate for our answer choices? The reason why there's not a y-coordinate is our equation was just a single variable equation. We came up with y in order to graph these two sides separately. So x will be the only solution to the original equation, so we just have x answer choices. The next question you might have is, why did we have to use second calc intersect here instead of just trace? And the reason why is our answer choices were so close that we required the exact point of intersection. So to get that, we have to do this second calc intersect method. All right, so you have two examples, trace and intersect. And both of these are important tools that will help you do these problems as quickly as possible. For problem 1, I'm not going to do this one, but as a hint, the answer choices are pretty far apart. So do we have to find the exact point of intersection, or could we just trace it? For problem 2, some of the answer choices are pretty close together. Do we have to use trace, or do we have to find the exact point of intersection? So these problems build in difficulty, and they'll let you practice the skill you just learned. Feel free to watch any part of the video again. Hope this helps. See you in class. Bye.